So today I'm going to be solving an energy problem found in the textbook on page 174, chapter 5, Work and Energy. It is problem number 8, and we'll start right now. So the written problem says, a block on a level frictionless surface has two horizontal forces applied, as shown in figure 5.28. What force, F2, would cause the block to move in a straight line to the right? If the block moves 50 centimeters, how much work is done by each force? Now, what is the total work done by the two forces? So first, since this is the energy chapter, we should consider what energy is involved in this problem. So we know that there is work being applied, so it's out of our system, and we can make our system the block and the earth. If we want to consider work as an external force, we need to remember that whatever work is being done is not included in the system. And we know that it's being converted from work energy into kinetic energy because the block is moving to the right. And there is work done and forces applied on either side of F1 and F2 to make sure that the block moves. So this work energy done by these two forces, which are external forces, create the movement of the block, which is the transformation of energy from work energy to kinetic energy. And this supports the law of conservation of energy because no energy is being lost, and if it is, it's being transferred to a different system. So the first part of the problem says what force F2 would cause the block to move in a straight line to the right. So I defined my sides being positive and negative, so I said the right side's positive, the left side's negative, top and bottom is positive and negative respectively. So we can be able to solve this problem. So we know that there is no net movement in the y direction because the block is only moving towards the right. And we can easily state that Fy equals 0. Now, we can look at the component forces of F1 and F2, and we know that there is a y component to each of these forces. So if we're looking at y components, we need sine 60 F2 and sine 30 F1. So that is stated right here, and we wrote that right here. So remembering that the negative side is the bottom, and that is where F1 is. Oh, forgot to put a 1 there, but now we have our equation for the forces, and we know that it's 0 because there's no net movement in the y direction. So is basically you manipulate the equation so that you get to solve for F2, that's what you want, and we get F2 equals negative F1 sine 30 over sine 60. And we know F1 equals 90 because it was given to us. So we can solve to get 52 newtons. So that is part 1. The next part of the question asks, if the block moves 50 centimeters, how much work is done by each force? So work equals force in the x direction times the distance traveled. So we need to remember there's still two forces being involved, so we need to break up into the components of each of the work forces. So the first work force is done by F1, and we are able to write out the forces because we have all the information already, because we've solved for it in part A, and we've also been given information that will help us solve for work. So F1 cosine 30 times 50, which is the displacement, equals 90 times cosine 30 times 50. 90 was given to us. Cosine 30 is the x component of the force in the x direction, and we get 39 joules. And F2 cosine 30 times 50, 52 is the force that we just solved for in the last problem. So we use that force. We're able to bring it back down and multiply that by cosine 60, which is the x component of the force, times 50, which is the displacement, and get 13 joules. And lastly, we need to know the total work. So all we have to do is add the components of the work forces as we solved for in the last part, and we get 52 joules, which is the total work done by these two forces. And I also forgot to mention that because of this energy transformation, we can also say that there is no other energy involved because there is a frictionless surface, so there's no opposing energy either. So we don't have to consider that when we're talking about work, or if we're considering that as part of our system, because that'd either be an external force or an internal force, depending on what we define as our system. So luckily we don't have to look into that because it's not part of our system, and it's not even existent because there is no friction. That's it. Thank you.